So just like you can work with segment addition, angle addition, you can work with setting two segments equal to each other and two angles equal to each other. There are things you can do to prove that certain angles are what they are, or that you can prove that those numbers we couldn't match up yesterday. Remember how there was an angle 1 that we couldn't match to one of the numbers? We could match angle 1 to everybody but that 1. Well, we could prove that that 1 is that answer if we just knew some of the other angles were alternate interior or corresponding, or some of the angles have the names that we've been looking at. And so today we're going to look at a few examples of how do you work with parallel line proofs. And typically, not always is the given going to be the lines are parallel. Sometimes you may be given something about the angles and you're trying to prove the lines are parallel. Sometimes you're going to start off with the given as the parallel, and you're trying to prove something about the angles. And so in this proof, they told me that line A and line B are parallel, and T is the transversal, and typically that's the letter they like to label the transversal, since the word transversal starts with a T. But when you have more than one sometimes in a picture, or more than one set of parallel lines, they may use other letters. And they have marked a few angles to help us to use them. And they really want us to prove 1 and 8. Now, 1 and 8 technically already has a name, and we probably could, say, well, gosh, I could just go say that. But that's not what they're wanting you to do here. We're actually trying to prove the rule that 1 and 8 are what they're supposed to be. What kind of angles are 1 and 8? Okay, they are obtuse, but I meant by location. Alternate exterior. So this proof that we're about to prove is the actual proof that proves the theorem that says alternate exterior angles are congruent. And as we go through this one, we want to make sure that we focus on anything we know about the angles in this picture. And this is one of the things I want to really stress with you. You can talk about corresponding all day long, and you can talk about vertical and supplementary all day long. And you can use those to help you to prove all the others. And so that's what we're going to look at in this question set, is what do I know about corresponding or supplementary or vertical? And maybe those can help me to determine that this 1 and 8 really is equal, because there are whatever you said. Can't think today. Same side interior, I'll call it that. Can't say the other word today. So let's start off with the parallel line given and see what else on this picture do we know besides 1 and 8. And so I do want to always state the given as much as possible. Now, if you don't like drawing all the lines in between it, you don't have to put lines. Use your notebook paper. But I will say this, that when I'm grading homework, it needs to be legible. A few of you, your homework last night was not legible because, number one, you squeezed it all too far close together, and I couldn't read, like, two things written in the same between two lines, or you wrote it too small, or there wasn't any space from one question to the next question, so I couldn't really tell when did you stop writing this one and start the next one sometimes. So be real careful not to squeeze in too much on a line.
I like, whenever I put an answer, I would draw a line to like the sentence.
Yeah, and so I saw that, and that did help. But it really is, if you got a lot to write down about a problem, it's really a good idea to skip a line between the next one if you've had a lot, especially when you're doing an A, a B, a C, and a D, and you're just having to write those two pairs of words, like the museum and the different ones. I really had trouble. Here's the first pair, and then the second pair was shoved up against it. It was really hard to distinguish if you had the right pairs, so I hope I grade your papers right. Because if I can't read it, I just put an X on it. So if it's not legible or I can't find it, I might have counted it wrong when it really was right. So, back to this proof. So I really want to focus not on the 1 and 8 right now, but on anything else I know about this problem. So tell me something about the angles in the problem besides the 1 and the 8.
5 and 8 vertical.
5 and 8 are vertical. Okay, that's a good choice.
Corresponding.
Okay, so they're on the same side, but there's one inside and one outside, so that makes them corresponding. So I've got two things I can talk about. And those are very good to talk about because they don't have to necessarily be, I don't know where I was going with that. I'll come back to that thought in a minute. Well, let's just start off with saying what you've talked about so far. So angle 5 is congruent to angle 8, and why are they congruent is because they're which kind of angles? Vertical. See, vertical angles are congruent no matter whether you have parallel lines or not. So see, that's a really good thing to start with because you don't have to have parallel lines to know that one. And the reason is vertical angles are congruent. That's the name of the theorem. That's what the theorem says. So they're not just vertical angles, but there's a theorem that says they're congruent. They're vertical by location, and they're always congruent, no matter what kind of lines you put them on. So that's something I could say, even if I didn't have part A, number 1, that A is parallel to B. Everybody did know this is the parallel symbol, right? So now let's go back and let's talk about the other one you said. So 1 and 5, are they always corresponding if they're in that location? The top left, is that always corresponding? Okay, but don't draw this part. But are they all, well, that looks too equal. Let me try that again. But are they always equal? What forces them to have to be equal? The parallel lines. Okay. So the idea is, without the parallel lines, I would not have that 1 and 5 are corresponding and that they're equal. They'd just be corresponding without the parallel lines. Does everybody see that? Okay. So I can say angle 1 is congruent to angle 5, but the reason for that, and it's a really long thing to write, so we're going to try to shorten it down, but let me tell you the whole thing, and then I'll tell you what we can shorten it to. It's actually a very wordy sentence. It says, if your lines are parallel cut by a transversal, then your corresponding angles are congruent. Now, we don't want to write all that, do we? So, therefore, we can boil that down, that whole entire sentence down to just basically two things. 1, the name of the angle, corresponding angles. Whoop, got the S before the corresponding angles. And then the other part is whether it's a postulate or a theorem. Now this one we wrote it out because it's a lot easier just to write that one out, even though that's the vertical angles theorem. Which you could also call this one that. If you didn't want to write this part, you could write the word theorem there. And you could say vertical angles theorem, and that's what the vertical angles theorem says. It's that short. Vertical angles are congruent. But this one's much longer, isn't it? So therefore, we can say corresponding angles, but this one's a postulate. How do you spell that? Off the top of my head, I'm not having a good day. L-A-T-E. Postulate. E. Postulate. And that's probably the only one that is a postulate. Most of the rest of them are theorems. So that way you don't have to write. Now listen to what all you would have had to write if you don't write that. 2 lines cut by a transversal such that corresponding angles are congruent. So that's a lot to write. Instead we can write the name of it and we don't have to write near as much. Now, in this proof, the idea is I try to tell everything I know about the angles that are vertical, corresponding, or supplementary. Do I have any supplementary?
No.
Okay. So, and when I say supplementary, I meant 2 side by side, not just 2 that make 180. So, when I look at these, though, I see something else that we have studied so far. If 1 is equal to 5, and 5 is equal to 8, doesn't 1 have to be equal to 8? And what property have we studied that says The transitive property. So therefore, we can say angle 1 is congruent to angle 8 due to the transitive property, because it allows us to take out the one that they're both equal to, the 5s, and put them together into one statement. And that's what somebody did when they proved that 1 and 8 are really that type of angle that you're talking about. And then someone went off and wrote a theorem that says if two parallel lines cut by a transversal such that alternate exterior angles are congruent. They had to prove it first to be able to write that statement. Transitive, because 1's equal to 5 and 5's equal to 8, so 1 has to be equal to 8 according to the transitive property. You can take out the middleman and put them together because they're both alike. All right. Does everybody see how that kind of proof works so far? This is a little bit different from what we did before. I'm not solving a question. I'm doing reasoning to try to prove something.
I just say it's right.
It sure would be nice if we could do that. All right. In this question, we're given something a lot different. So we want to look at starting with angles and going back to parallel lines. I'll give you a minute to get all that down. Now, I've got a lot more angles on this picture than I need. I do not need all these angles to prove this, but this was a picture we already had somewhere else that had all the numbers on it, so I just wanted to use it again to make this question. And the nice thing about this particular question is there are a lot of perspectives I could use on this question on how to work with it, and I could prove it. So I don't have to pick a particular angle. One person can maybe pick a pair of angles different from somebody else and you still be able to prove it. It just depends on which perspective you're looking at. And I'll show you that as we go along, but we'll decide on a particular perspective. Now, they don't always do these proofs from the same kind of givens, but they a lot of times give you some information either about the lines being cut or some angles being congruent, and we have to figure out how to get to these lines of parallel. And the best thing you can do is get to corresponding. Because if you can get to corresponding, then you can use the corresponding angle postulate that works both ways. See, not only does it say two lines cut by transversal that are parallel to make corresponding angles congruent, but if corresponding angles are congruent, then the lines cut by the transversal have to be parallel. And so the whole point of these types of proofs is try to stick to vertical angles and try to stick to corresponding angles as much as possible in setting up your question. But 1 and 8 is not one of those, is it? So they gave us that to kind of give us started. And that's kind of one of the things we need to use when we're going to work our question. But first, let's start off with there's two pieces of this given. There's a given statement about which lines are doing what, and there's a given statement about the angles. Let's start with the two lines being cut by the transversal. That's our first given. Now, the transversal T cutting lines A and B I don't know they're parallel at this point other than just looking at the picture, right? There's nothing in there that says they are, so we're going to try to prove that. In order to prove that, we've got to be able to have some angles that we do know something about and work with it. So first of all, you can always do something with vertical. And you could always do something with corresponding. But the key here is they gave me 1 and 8 was alternate interior. And so they want me to use that. So I'm going to try to show you how we can use that. So this is our given. And then we're also given in step 2 that angle 1 is congruent to angle 8. That's our other given. Sometimes you can list both givens from the get-go, and sometimes you might want to hold one till later. And this proof it won't matter. But I'm going to go ahead and write them both and get done. Now, I'm comparing 1 and 8 in this statement, and I've got there here. It sure would be nice if I could prove something about corresponding.
What is
Okay.
3?
1 and 3 are corresponding if 1 would be reused, right? That's going to be bad on my video. Oh well. And then what if I wanted to use 8 instead?
6 then.
Okay, 8 and 3 are vertical. Or I could go 8 and 6 are corresponding because 1 and 6 are vertical. Does everybody see that? Yeah, I'll take a drink of my... Let me stop the video a minute so I can stop. All right, so the key here is we have to choose a perspective on which of those particular corresponding angles we want to use, and we could do it either way, y'all. We could go with saying, well, I eventually want to get to the 3 and the 8, excuse me, the 1 and the 3, or I want to do the 8 and the 6. I could go either way. Now, I personally have set it up to do it with the 6 and the 8, but I could go back and do it with the 1 and the 3, and it would work. But it doesn't really matter which way you go there. That's why there's so many angles on this picture, and you could have a little different perspective, and we actually could have totally 2 different proofs work and both of them be right. Because I could go with either one of those as long as one of them has one of these 2 angles in it, the 1 and the 8. So I get to choose. Well, I'm going to go with the 6 and 8 because that's what I've got written down. Eventually, that's what I'm wanting to get. And so I really want to focus on that 1 and 6 because they're vertical. Does everybody see that? So I'm focusing on a little bit different perspective than if I did the 1 and the 3. So 1 and 6 are vertical. Do the lines have to be parallel for me to know that? No. You can state vertical angles all day long. You do not have to have parallel lines to have vertical. So we have the vertical angles are congruent. Now that I have the given 1 and 8, and I have the vertical angles are congruent with 1 and 6, what can I now state?
1 and 8.
8 and 6.
And what rule allows me to do that based on these 2 statements? Transitive. So we're using transitive again. The idea was to try to get the 8 and the 6 together because 8 and 6 were our corresponding angles. But that's not the reason. The reason is transitive. I used the transitive property to put the previous 2 statements together to make me a pair of corresponding angles are congruent for a reason. So now that I know that these angles are congruent, and from my picture they're corresponding, because they're in the top right on both positions, then I have the situation of doing the opposite of what I did on the first proof. I now can say the corresponding angles are congruent, so the lines have to be parallel if they're cut by that transversal.
So what if you just put, what if you did put corresponding? Would it be wrong?
Here?
Yeah.
Yes, it would be. Because you have nothing about parallel lines to know that those are congruent by the corresponding rule, because I don't already know the pot lines are parallel. I haven't proven that. So now I can say A is parallel to B because now I do have corresponding angles are congruent. And the reason over here is the name of the angles There's a lot to do with the reason. The lines are parallel, makes these equal, or these are equal, makes the lines parallel. But instead of being the reason we looked at earlier, that the corresponding angle postulate, it's the inverse of that because we're going backwards. We're starting with the angles and going to the parallel lines. In this one, we had the parallel lines, so we stated the corresponding angle postulate made these congruent. When you go backwards and you're going to parallel, you say it's the inverse. So this is the inverse corresponding, and we can abbreviate corresponding if you want to, angles postulate. And let me go back and reiterate again to you what those say. The original corresponding postulate says, if two lines parallel lines are cut by a transversal, then corresponding angles are congruent. The inverse corresponding angles postulate says, if the corresponding angles are congruent, then the lines have to be parallel that were cut by the transversal. Does everybody see how the two are just, we switch what they say? So if it starts off with, if they give you parallel lines, then it's the name of the angles. If you're proving the parallel lines, then it's the inverse of the name of the angle. But notice that when I worked this, I couldn't just go straight to corresponding because I have to know more about the picture. Because I don't know the lines are parallel, I can't just go straight and say they're congruent. I have to work around that. All right, any questions about this one? Well, as always, sometimes having supplementary angles and vertical angles can help. So we did a couple with vertical angles, so I thought it'd be good to go back and look at something that used supplementary. And in this problem, the given is that 3 and 5 are supplementary. But 3 and 5 are really what?
Same side interior.
But I'm not going to use that because that's a theorem, and if I use that, I have to do a longer proof. So that's why I gave you that. Okay? But I'd like to prove that 3 and 6 are congruent, which are my alternate interiors, right? See, I don't know they're congruent. I just think they're congruent because they look it, but I don't know that. I will only know that if the lines are parallel.
And because it says 3 and 3 is congruent.
Right, and we're trying to prove that. And the thing is once you kind of go through some of these proofs and you see how they work, you can see why the lesson we learned yesterday can be done without writing so many reasons. Because you'll understand why some of them are equal and why some of them are supplementary. So we're going to start off with the given, and we're going to try to see where we can go with proving that 3 and 6 are those alternate interior angles that are congruent. So as always, state the obvious. The given. Now, eventually we're going to be able to put 3 and 6 together. And right now we have 3 and 5. So where do you think I should go next? Thinking about what we've been doing so far. What do you
4, 6.
Okay, well, let's talk a little bit about some of those. 6 and 2 are corresponding. For me to be able to do that, I'd have to work around through vertical. Not that that's not possible. I'm just giving you some options here. All right, somebody said 4 and 6. I can't prove those two are congruent because they're the ones that's the new names that we're learning, okay? So if I go to 4 and 6, they would have to tell me that, and they haven't told me that. The only things I can use, let me refresh your memory, the only things I can use are vertical and regular everyday supplementary angles that really are supplementary to each other because they're side by side. Those are my only choices if they don't give it to me.
5 and 8. 6 and 8 work? Or
Okay, so I could do something with 5 and 8 because they're vertical, and you're saying that maybe I could do something with 5 and 6 because they're supplementary. Those are things I could pull off this picture that I don't have to have parallel lines to know those, right? And that's kind of where you want to go. Now, in the previous examples, let's go back just for a second. I was talking about congruencies. And so because I was talking about congruencies, I typically, was looking for angles that were congruent. And then I say that another one was congruent, so I could put the two congruencies together and say they were congruent to each other with transitive. So since I'm given something that's supplementary, it might be helpful if I had another supplementary. And the reason it might be helpful that I have another supplementary is because we could look at the equations of the supplementary and see what we could do with it. So if you got one supplementary, you might want to find another one. So I think your idea about the 5 and the 6 might be a really good place to start, and then we'll see where we can go with it. And if we can't get there, then we might come back in and bring in a vertical angle or something else. So angle 5 is supplementary to angle 6, not because it's one of our names of our angles that are special, that have to have parallel lines, because they're just regular everyday definition of supplementary angles. The definition of supplementary angles is two angles side by side on a straight line. So I can write that for that. I would never have been able to write that for 3 and 5 if that hadn't been given. Because 3 and 5 are not side by side, are they? They don't touch. They are on a straight line. So therefore, I could not have written that for that reason. That's why they had to give me that one. Now, if 3 and 5 are supplementary, what is the equation for that supplementary angle? How do you write a supplementary equation for two angles at
5 plus 6
Okay.
and 8.
And what can I do for the 3 and the 5? The same thing?
3 plus 5.
All right, that's what we're going to do. And those are both in one step together. They are both step 3 because we did the same reason for both of them, right? Everybody agree? That's a good question. Very good question. Yeah, once in a while there is. Like it's so obvious it's just like your nose on your face kind of question. Let's move that down there. I'm going to go back and give that one a different name. You need that one for down there. The definition of supplementary angle says they add up to 180. Not that this doesn't, but this one can have a different reason.
Just draw what area.
This is definition of linear pair. Let me tell you the difference between those two definitions. Linear pair definition says they're supplementary angles. Okay? The definition of supplementary says they add up to 180. So if they use the word supplementary in here, that's because they don't want you to think the 180 yet. And that's the definition of linear pair, because the definition of linear pair again states two angles that are supplementary to each other. See how that definition doesn't say anything about 180? The definition of supplementary is two angles that add up to 180. So even though they both kind of mean the same thing, they're used a little different. Does everybody see that? And I recognized that as soon as I got to the next step because I realized I couldn't write the same reason twice because it wouldn't have been the same reason twice. So now I have two equations equal to the same thing. What do you do about that? That's right. the measure of angle 3 plus the measure of angle 5 equals to the measure of angle 5 plus the measure of angle 6. Now, actually, there are two different reasons that you could put and get the correct answer for this question, but based on what we've been studying today, if you have two things equal to the same thing and you take the middleman out and make them equal to each other, what property did I just use? Transitive. But I also could say I substituted, because I could say 5 and 6 substituted in here for this 180, and that would also be correct. But since we're trying to focus on transitive, I'm going to put transitive because that's really what I wanted you to use. But the transitive is just a special substitution. That's all transitive is. It's a special substitution rule, and once you take the first equation, you take out the 180, and you put in the second equation's part for that. That's what transitive is. It's just a special substitution. Now, what do you notice about this equation is that both of them have 5 on both sides, right? Wonder how I could get rid of that. Subtract. Everybody see that? We can subtract the measure of angle 5 from both sides. So step 5, take away the measure of angle 5 from both sides. And we use the subtraction property. And what will be left? Whoop. Throw the marker around. The measure of angle 3 equals the measure of angle 6. Everybody agree? Okay. Substitution. Bobby, this isn't what you think of substitution because I didn't really change much, but I dropped out the stuff I didn't need anymore. So number 7. Let's look at what we're trying to prove, and let's look at where we're at. I got the right angles. Everybody agree? And these are the corresponding angles, right? But I don't need that for the reason. You see, nowhere in this proof does it say those two lines are parallel. Right? So if they don't say anything about parallel, I can't use the name of the angles. I have to use something else. But the next reason is real simple. Because I can go straight to saying if they're equal measure, they're congruent. I mean, that's just obvious, right? If they're equal, they're congruent. Because the definition of congruent says that they're equal. And that's your reason. Definition of congruency. So the definition of congruency says if two things are equal, then they're congruent. Now, there's plenty of other ways I could have gone about doing this one. This is just one way to do it, and that I wanted to show something with supplementary so you kind of could get a chance to see some supplementary work. But there are plenty of other things I could have done and maybe done it a little differently. And sometimes you can even do them shorter. I don't know that I could have shortened this one up a tremendous amount without going a totally different direction. So every proof doesn't have exactly one way it can be done. All right. This one we're just going to do verbally. We're not going to write it down necessarily, just to save a little bit of time, because it's kind of long. This is what they call a flowchart proof. A flow proof is just they've got everything that was in the statement side in boxes, and they put the reason right under it, and sometimes they show you which two things merge together to make the next statement, and sometimes it's just going straight across because it's just the reason for why that happened. And so in this problem, they're telling me angle 1 and angle 4 are supplementary, and we're trying to prove parallel lines. So that means we've got to know the name of some angles to be able to prove parallel lines. So the first one says they're supplementary, so what would I write on that line? This is the reason. No, the reason. What's the reason I know this box? It's given. So you don't have to write this one down. I'm just trying to give you an idea of how you can take, instead of doing a 2-column proof, you can do a flow chart. All right, so if 1 and 4 are supplementary is given, then this box must not be given. So we need to look at the picture and see what is this box all about. So it says 1 and 2 are congruent. And then it says 3 and 4 are congruent. What kind of angles are they? Oh, okay. Vertical angles are congruent. There's your reason. So in the box is the statement, and underneath it is the reason for that statement. Now, they tell me I'm going to be doing some kind of substitution over here. Not sure exactly what kind of substitution I'm trying to do, but they're saying I need to do some kind of substitution. So obviously they want me to take something here that I want to work with and replace something in here or vice versa. And I would think it would be here to go to there. So I probably need to look for some other angles over here that we know the name of that I don't have right now. So what else can I compare? What kind are 3 and 2? Same side interior. Are they supplementary? Okay. Could I do 1 and 4? Same side exterior? I could do either one of those. So this is the place in the proof in which 2 students could have the same answer. To the proof, they could show different steps, but really get to the end and have the right answer, but with different steps, because it depends on which one of those you want to use. No, 2 and 4 would not work because they're alternating, but they're not both inside or both outside, so therefore they wouldn't be corresponding either, and therefore I could not use that pair. All right, so I'm going to take this expression right here and try to focus on the fact that I really would like to get to the 2 and the 3. So if 1 is equal to 2, couldn't I take this 1 out and put in 2? And I can't write in that box, so I'm just going to write it up here. And if 3 is equal to 4, couldn't I take that 4 out and put the 3 in for it? Everybody agree?
What did it say right there?
Where?
Angle 2 and angle 3.
Uh-huh.
That was just right.
Angle 2 and angle 3. Yeah. So I'm just taking out the names of the angles and substituting in the other name that it's equal to. So they are supplementary. So since they're supplementary angles, and they are those same side interior, or what we call consecutive interior, that proves that they're parallel, because I've proven that those 2 angles are supplementary. So what's our reason for that? Well, what's the name of the angles I'm talking about?
So,
No, the other name, where they're located, name. All right, same side or co-side. Now, you can use either one of those. I don't care which one you say, consecutive or same side interior. That's up to you. But I'll say same side because it's shorter to write. Yes, it is. And that's a theorem. So because the same side interior theorem says that if you have 2 angles that are supplementary on the interior of the parallel lines on one side of the transversal, then the lines have to be parallel, because those are supplementary. And because I start with the angles and go to the parallel, this is the inverse. If I was doing it, I got the parallel and going the opposite direction, then if the 2 lines are parallel cut by a transversal such that same side interiors are supplementary, if I end it with the word supplementary, it's just a regular theorem. But if I end it with the lines are parallel, then I have to put the word inverse in front. So this is just another kind of way of writing a proof, in which you can see how you can merge statements and be able to substitute them in together or make them equal to each other or whatever it takes to fill in each blank till you get to the end instead of writing it in 2 columns. It's called a flow proof. And then the other kind of proof is called paragraph proofs. And you technically have kind of got started on that when you started doing angle 1 is equal to 100. Now angle 2 is supplementary to it, so it must be 80. You kind of were writing paragraph proofs, you just weren't putting in full sentences, because that's kind of what you do with that. Any questions? All right.